So now we're going to expand on our understanding of probability and take a look at what is experimental probability and how does it differ from theoretical probability. So remember, theoretical probability, which we've talked about in the past, it's all about what we would anticipate in theory. What would we expect from a certain outcome? Okay, so like we would expect that every time that we flip a coin, it's a 50-50 chance of getting heads and tails. So now if we would flip a coin 10 times, we would expect to get 5 heads and 5 tails. Experimental probability is a little bit different. Experimental probability is an estimate of the likelihood of a certain outcome based on repeated experiments, which is kind of expected when we talk about experimental or experiments. Okay. The more experiments that are done, the closer to the theoretical probability it will be. Okay, so that's what we're expecting. So when we're doing this estimate, or we're kind of going through and doing an experiment in science or something, and the more often that we do something, the closer to what we would expect to happen is probably going to happen. So let's just take a look here. Now, normally I would probably have you do this in class with a partner, but we're going to take a coin. I have a Canadian quarter here. You'll notice that has tails on this side and it has heads on that side. And I'm going to flip it 10 times. Okay, so I'm going to flip it 10 times and I'm going to record the results. I'm going to flip it and put it on my hand there. Okay, so the first one's tails. And then the next one is heads. Sorry about that. And then we have tails again. Now, when we're looking at this here, I would probably expect to get a heads next time because, well, it's every other. Sure enough, it's a heads. Tails. Heads. Wow, this is incredible, actually. Heads. Okay, here we go. Our pattern is now off. Tails. Heads. And final one. Oh, fell. But it landed as a tails. That one fell on the floor. Okay, so landed as a tails. So I do this 10 times and go through it, and you'll notice that there's 1, 2, 3, 4, 5 tails and 1, 2, 3, 4, 5 heads. So the probability of it landing heads in this case here, when we talk about theoretical, we're talking about the number of times it should happen, or number of possible outcomes, and the number of expected or wanted outcomes. Here we're going to do the number of outcomes that happened, so 5, out of the total number of outcomes, which is 10. So pretty similar. And if we simplify that, that's going to be 1/2. Now, the probability of tails, as you can probably guess, same thing, 5 out of the 10 times, which is 1/2. Now, in this case here, we have absolutely nailed the theoretical probability in this case here as well, which I'm going to say is pretty incredible. Actually, I think if you look at the notes that go along with this video here, there are different notes that I've used in the past, but I also got 5 and 5 in here. I've done this with a number of different classes now, and these results are varied. I think one time I got 8 heads and 2 tails, which is completely different than what we would expect. But this is what our experimental probability is going to bring about. So the more often we do this, it should get closer and closer to 1/2. In fact, here we nailed 1/2. Now let's try a dice. Okay, so a regular die, and let's see what we get with the results. We get a 3, a 5, another 5, even if you can't see it, a 3, a 1, a 3, Might be a weighted die here. It's a 5, a 6. There we go. We got an even number finally. A 4, and come on, a 2. Oh, another 4. All right, so when we look at the probability of these ones here, the probability to roll a 1, in this case here, we got 1 out of 10. Okay, the probability of a 2, we didn't actually roll 1, it's 0 out of 10. Probability of a 3, 1, 2, 3, so we got 3 out of 10. Probability of a 4, we got 2 out of 10. Probability of a 5, 1, 2, 3, 3 out of 10. And probability of a 6, we got 1 out of 10. 1, 4, 6, 10. Okay, good, all 10 of mine there. Now, you'll notice with these probabilities here is that they're very different from what we would expect. Okay, this is 10%, this is 0%, this is 30%, 20%, 30%, and 10%. Okay, now these percentages here are very different than the theoretical or the expected, I'll say expected, 16.67% that we came up with in our theoretical probability. This is the theoretical probability we expected for every single one, but we're getting ones that are very different between 0 and 30%. Now, some are what we would kind of expect, 1 to 2 in a span of 10, but this is, again, a very small sample size. If we were to do this 100 or 1,000 or 1,000,000 times, we would expect that our probabilities would be a lot closer to the expected or theoretical values. So this is what we get from experimental. Theoretical is a little bit different, is what we would expect to happen, not what is actually going to happen inside of our experiment here. So let's just go through a couple questions here. Let's use the result to complete the following. A coin being flipped and landing on heads. Well, we've put this in there already, but our probability of heads in this case here was 5 out of 10, which is equal to 1/2, which is 50%, which is 0.5. Exactly what we expected, okay? It's completely what we expected, okay? So this is the expected result. A rolled die will land on 3. Well, if we look at our chart here, it was 3 out of 10 times. So the probability that we got a 3 was 3 out of 10, which is 30%, which is 0.3, which is higher than expected. And I'm going to put in here 16.67%, which is our expected value. So our probability to roll a 3 when we did an experiment is a lot higher than we would have expected. Now the final one here is a rolled die will land on an even number. So this was kind of that last one that we did with our theoretical. So our probability of having an even number, we had 0, 2, 3. Was 3 out of 10, which is 30%, or 0.3, which is lower than expected, because we expected it to be 50%, or 1/2. So in other words, this is a lot lower. Now, what we'll notice here is that the heads one was nailed exactly on, which again, sometimes happens, sometimes not. All depends on the result that we get. Whereas the 3, okay, was a lot higher than we would expect. We would expect 16.67%. And the fact that it's an even number was a lot lower than expected. We expected 50% and we only got 30%. So again, the experimental is a little bit different than the theoretical is a little different than what we happened with our experiment. Okay, so what we could do, and if we have some time, we will do a little experiment where we'll try 100, and we'll go through with a partner, and you'll work through trying to see what happens if we do roll a die 100 times, what happens if we flip a coin 100 times. Do we get very theoretical probabilities, or are we still very far off from our estimates? Okay, so that's the expected. The more often we do it, we would expect to get more closer to our theoretical.